Okay, in today's talk, what I'd like to do is to take the opportunity to talk a little bit, tell some stories about some of the opportunities that I've had to try to deploy some strategies for helping people with adaptive management, and then at the same time sort of try and outline how to identify the particular instances in which an ecologist's contribution to management, or the opportunity to make a contribution to management, varies according to the different kinds of circumstances that you might find yourself in. So as we heard in a range of talks over the last few days, environmental decisions are really hard, and adaptive management is the solution. And this was really the sort of take-home message from Steve Light, Lance Gunderson, and Buzz Holling's book, Barriers and Bridges. And sort of, I'm not necessarily in disagreement with that, but I'd like to sort of offer up the opportunity that maybe that's not the whole story. Maybe there are certain circumstances in which adaptive management is not the solution, or not necessarily the whole solution. So here's a bit of an outline for today's talk. I'm going to start off by talking about what I think, what you can think of as the adaptive management menu, because there's many flavors of adaptive management, and the term gets used a lot, and I want to try and lay out some kind of a bit of a roadmap, if you like, or a menu of how to think about the range of different possibilities. Then I'm going to tell a little bit of a story, go into storytelling mode, talk about the Missouri River and Platte River habitat restoration programs, and that sort of sets the stage for how I got to where I am now. The next thing that I'd like to do is to talk about what I think of as the many faces of uncertainty, or many different definitions of uncertainty, and to this is important to sort of talk about what is meant by uncertainty, because it's right at the heart of adaptive management as a concept, as an approach to things. And I want to sort of lay out a new sort of umbrella concept that I'll call indeterminism, for how to approach this diversity of ideas in a broad and holistic kind of way. Then what I wanted to use is take this indeterminism concept and use it to lay out a way of sort of classifying the range of possibilities that you could see, the circumstances that you could find yourself in as a scientist, and then to try and understand how does the role of science vary as we move about on this landscape. And then finally, I want to end up with some thoughts about what do we do on the right-hand side. And that's not necessarily going to make a whole lot of sense to you right now, but once I lay out the roadmap to indeterminism, it'll make more sense. Okay, so a few years ago now, I asked a graduate student of mine, Jamie McFadden, as part of her thesis to try and do a literature review on adaptive management. And the goal was to see if we could try and identify characteristics of adaptive management problems that would predict success or failure. Well, one of the big difficulties we ran into immediately, or that Jamie ran into, I use the we loosely in this sense, was that it was really hard to define success for an adaptive management program. It was also hard to find examples of adaptive management programs in the literature. But one thing that we were able to do was to sort of classify a lot of these examples according to what sort of general approach to adaptive management that they used. And we kind of came up with two main, what we called schools of thought. And the first is draws heavily on the literature, starting with Buzz Holling's work, which is really sort of origins of all adaptive management thinking in many ways. But draws heavily on that and really focuses on things like experimentation gains knowledge, and resilience is a key goal of adaptive management. On the other side, you have a sort of a view that is well characterized by Hugh Possingham's paper from 2000, but many others as well, including actually Carl Walter's 1986 book. This really talks more of a decision theoretic school, is what we describe that here. And in this case, experimentation, although highly valued, is not necessary to do adaptive management. And resilience is not necessarily an objective, although it could be an objective if you could figure out, in fact, how to measure it. These two schools of thought share a fair amount of stuff in common, such as iterative process. In other words, you're repeating decisions over time in order to reduce uncertainty. You're monitoring in order to do the learning that allows you to reduce uncertainty. A collaborative sort of approach to including stakeholders and managers into the process, and again, this notion that uncertainty, making decisions under uncertainty, is what leads you to adaptive management. And in fact, many of these features, and particularly the iterative process and the collaboration components, are what a lot of social scientists sort of glom onto when they're thinking of adaptive management as being quite useful, because these features, in a lot of sticky governance situations, are also quite useful, although they're not necessarily well articulated in the resilience experimentalist school or the decision theoretic school. There's actually a third school of adaptive management that I've just come across. The Rule and Fishman are two lawyers who wrote in a 2010 paper in the Minnesota Law Review, described what they called AM Light, which really is a focus on iterative process and monitoring, but not necessarily on some of these other features of that. And they really regarded AM Light as a way in which a lot of agencies in the U.S. federal government were trying to utilize the ideas of adaptive management, in particular the iterative process and monitoring components, to gain discretionary powers in the face of applications of the National Environmental Protection Act, which sort of requires things to be sort of nailed down up front. And so they were sort of been hoping to kind of gain some ability to sort of not have things so nailed down and carry on out into the future. Of course, the U.S. courts have rather rejected this interpretation of adaptive management, and so it hasn't necessarily generated the kind of discretionary power that perhaps people would like, but nonetheless it's out there. Okay, so story time now. How did I get to where I am, where I've been thinking about these things? In 2008, I was invited to participate at the National Conservation Training Center as a coach for a group of Fish and Wildlife Service and Army Corps of Engineers staff who were interested in this particular problem up here, implementing an adaptive approach for the recovery of tern and plover populations on the Missouri River. The cast of characters that's listed down here at the bottom is in fact not that particular group of people. Craig Fleming from the Corps of Engineers was a part of that original group, and Tim Flieger was as well, but a lot of these other folks were sort of contractors and other staff that came on board at later stages as we went along. And in that 2008 workshop, what we were aiming to do was to try and do a structured decision-making, sort of rapid prototyping exercise, this sort of procedure that's been worked out for trying to very quickly see if you can draft up an approach to a problem. For those of you that aren't familiar with it, here's the Missouri River Mainstem reservoir system. You can see up here in this little inset map, this blue area here is the drainage basin of the Missouri River, and this is where it joins up with the Mississippi. And the key thing about the Missouri River Mainstem system is that it's both channelized down along this stretch here to maintain, to allow navigation up to Sioux City, and it's also has a series of dams that have been, that were put in place between 1933 and 1959, primarily for flood control and navigation purposes, and then later on Congress sort of modified things a little bit to include fish and wildlife and recreation as valid authorized purposes for the operation of the Missouri River Mainstem system. Well, that's all well and good. So the system started operating in the sort of fully filled up about 1967, and really began its sort of continuous operations then at that point. So why is that a problem? Well, so here's a picture of the a portion of the channelized portion of the Missouri River, and you can see there's sort of wing dikes here, which are designed to sort of channelize the flow, push it into the center of the thing, and maintain a sort of an open channel 300 feet wide, 9 feet deep for the purposes of navigation. And the issue here is that this river was not ever really that narrow. It would typically spill out and be extremely wide and have a very variable hydrograph, variable depths, lots of heterogeneity. A lot of that heterogeneity was habitat for species which are now endangered. Here's another similar problem. The Platte River Recovery Implementation Program is responsible for habitat restoration for the same species in this reach right here. And again, there's dams both on the South Platte up where it runs through Denver, and then all around in that area, primarily for drinking water control and also for irrigation. There's a large reservoir here in western Nebraska that also manages for primarily for irrigation water control. And so as a result, again, the hydrograph is very much modified from its historical state, and so you don't get high flows. The river doesn't spread out over miles and miles anymore. They used to describe the Platte River in the 19th century as a mile wide and an inch deep. It's not like that anymore. Where it still has water in it, it's pretty stable, and what you get is these sandbars that are here in the middle of the channel. Get a lot of vegetation on them. And a similar kind of thing happens on sandbars in the Missouri River, where there are sandbars, so the channelized portion doesn't have sandbars at all. But farther upstream there are sandbars, but they get vegetated. And why is that an issue? Well, it's a big issue because of these two characters. Interior least tern, which is listed as endangered in 1985, and the northern Great Plains piping plover population, which was listed as threatened in 1986. Turns out now that maybe they should have been done the other way around in terms of endangered versus threatened, but so those are things that are under review at the moment. But the key thing that both of these species like is they like to nest on bare sand. Okay, and if the sand is growing vegetation, it's not bare, and they don't like to nest on it. And so that was sort of the discussion that the Corps of Engineers and the Fish and Wildlife Service really entered into in the late 1980s. Was about how they were going to operate the Missouri Mainstem reservoir system and avoid jeopardy to these two species in particular, but also one other species, a species of fish, which I'll talk about in a little bit. So this sort of created an enormous amount of friction. I mean, in the Missouri River system, the triggering thing was the negotiations over the master manual, how they're going to operate the Missouri Mainstem reservoir system. And that took over a decade of discussions and negotiations before a final sort of biological opinion was discussed. And even at that point, it still wasn't a done deal by any stretch, because the Fish and Wildlife Service had agreed that although the Corps did not have to modify the hydrograph, they did have to do adaptive management with their habitat restoration in order to prove that it was working. However, they didn't really describe what had to be done in order for adaptive management to be achieved. So in no way, there's no way really of defining what success looked like. And that was the sort of situation in 2008 when I was asked to sort of sit down with these folks and say, okay, how are we going to get to adaptive management on this system? And really the decision, the underlying question is, how do alterations in available habitat affect populations of piping plover and interior least tern? And a very similar question was present on the Platte River program, and I was asked later to work with the Platte River Recovery Program to sort of discuss those kinds of approaches. So, we sat down, we did this week-long workshop, we laid out objectives, we defined alternatives. Then they liked what we did during that workshop so much, we came up with some simple models there that they asked us, Craig Fleming in particular asked me to continue to be involved, and we continued to make the models more and more sophisticated. And we came up with, in the end, things like this, sort of projections of future conditions of the populations under different sorts of scenarios. So in this case, what you've got is two projections, and these are median population sizes, not showing the range of possibilities. And for, in one case, what the Fish and Wildlife Service biological opinion said needed to be done in terms of construction, the sort of the Corps' existing program, and then just for interest's sake, what would happen if they didn't build anything and just let things carry on as they go. And these projections here you can see are starting in 2009, but we did various exercises like back up and try and hindcast the what had been observed and then go forward from there. So here's the population goal for the plover populations from the recovery plan. And what you can see is that all three of these possible future construction scenarios will meet that goal within a span of about 4 different years. So what are the problems that arise with this? Well, the first problem is that the Corps' existing program is not as good as what the Fish and Wildlife Service wanted, so the Corps didn't like that. And the second thing is that not doing anything is not a whole lot worse than doing something. And the Fish and Wildlife Service didn't like that. So basically, nobody liked any of these projections. And a very similar sort of outcome for terns, although because of the way their life history is, it's a little more stretched out. They don't breed quite so quickly. The responses are, if anything, even more attenuated and even more drawn out. And if I was to lay on top of these medians the uncertainty in these projections, which comes from a wide range of things about the uncertainty about the parameters, variation in the hydrograph from year to year, all of that kind of uncertainty rolled in together, then what you would see is there's really not a lot of differences between the range of possibilities. And so a lot of what is going to happen in the future is independent of what the Army Corps does, and it's really driven by what the hydrograph provides, even within the constrained level of what the Army Corps of Engineers is operating.